So before we continue the class, let us review what we have learned for the continuous random variable, and then we'll go to normal, and then we will hopefully cover some of the Excels. Okay. So to review, let us go back to consider the random variable, right? Last class, we talked about the cumulative probability function, because continuous means you can't list all of them, right? So that means that you have to have some way to describe them, right? It's not, you cannot tell what is probability of such thing, right? Because you cannot count all of them. So we have to way to describe a bunch of those together at the same time, right? So one natural way is consider the cumulative one, right? Which means that the random variable is less than a certain number, right? That is here we have the probability x is less than x, right? So that is the main idea behind okay. So then you take the derivative, will give you the density function. Okay, so and this little bit tricky, but the main thing you need to remember is the area under the curve would be the probability. Okay, so that is by the way, can you hear me? In case I haven't asked that before, so good. So so that's the idea. So the next thing we would like to discuss is the expectation. Okay, and just to recall the discrete case, right? The summation of x times px, right? The value of x times the probability function, right? But now we have a continuous, then you have changed the summation, right, into the integral, right? Because now we're adding, but we're adding too many things together, very small stuff together, then we need to use integration, right? And the variance, the same idea, right? The variance in a discrete case, right, is summation, right? Y minus exponential y, okay, times square times probability times py, okay? So just to this is just to recall, we discussed it in detail already, but okay, in case you have, okay, some have question. Oh, some of you asked me how to upload the assignment. You just go to the Blackboard and then you click, and then you will see, let me see if I can show you. Just wait a second, let me see if I can show you the way to do it. Okay, some of you haven't submitted the assignment before. Just wait a second. So maybe I can show you the share screen from Google. So this is, I think this is what you see from your share screen, right? Kai-chung, right? So here is the assignment, right? I think this is where you got your assignment, right? Here is the thing, right? Here is the assignment. You can write down your topic here, and this is the sample, and this is the homework file, right? Or you click this one. Kai-chung, can you see? And then click inside, and then here you go down here, you can have submission, right? Attach file. then you're done. Okay. I think I allow multiple attempts, so we just if you submit and then you don't like it, you can submit again. Okay. We will grade the last one. Okay. So we don't look at every submission you do, but we will grade the very last one. Is that okay? So let us go back to the review part. So, and then I think in the last class we covered the uniform and exponential, right? And some of the normal. So today we'll touch a bit on normal and then give some idea of the chi-square and student T and F, okay? And because later you will see the normal chi-square, student T and F are all do not have a closed form expression. So we rely on the Excel to do the calculation. So we will touch on those, okay? Very soon, because when the calculation we need it. But let's quickly review what we have done. So uniform is saying that everything is equally likely within within the relevant range. So between A and B, so this A and B, okay? This means that if you pick a length of say length of a size, say called 1, say 1, and another non-overlapping range also 1, okay? Where the overlap doesn't matter, but the probability of a number being drawn here and here are the same, okay? So as we said, this area in the curve, right? So basically this is a B, this is A, and this is with the height, right? This height is 1 over B minus A, okay? And the frequent we use is the distribution function, which is x minus A over B minus A, okay? This is the mean and this is the variance. We give you an idea how to prove it, although we didn't go through every single step, but you know the idea to get those, okay? So these are the things that the one I circle would be the things that you need to understand or you need to remember, right? And the proof would not be the main thing, but you probably need to know how we arrive them, right? Okay, so this is uniform. And the next one we cover is exponential. Okay, we covered it in the last class. It's exponential, right? Just to recall, what is exponential? It just related to the idea of a binomial trial, right? Okay, or indeed it related to Poisson, right? So it just binomial trial, right? Is a there were n trial, okay? N trial, okay? Each one will be probably be P of success, right? 1 minus P is failure, right? And if N is large, right? P is small, right? NP is positive. Then in that case, this how many event within here will become a Poisson, right? This become Poisson, okay? Poisson is the number of events in this interval, right? And when we look at what is the time that the first event will happen, okay? Time until event happens, okay? Will follow what we call the exponential, okay? And that's how we arrive this guy, okay? And we are not going to explain why we get this one because of the out of our level. If you want, then probably you need to study intermediate probability theory. So we just tell you this is related to this one. And to formally show this is the time, is not our main concern. But this is and motivation, right? But at least this means that this is a random variable that takes the value from 0 to positive infinity. And the discrete function is integration. But anyway, this is the thing that you, in your mind, okay? And this is the mean, and this is the variance. Okay, just make sure that the typo is not, there's no 2, right? There's no this. No, this is wrong. We don't have the 2 here. Okay, so that is the thing. Is that okay? Any question? Okay, that's a question. Oh no, just people say hi to me. Other than that, any question? Okay, if no, then we will be doing the next part. Okay, it's called normal distribution. Okay, normal distribution is what we call the Gaussian. Okay, it's invented by Gauss, mathematician. I think he used it to for astronomy reason. I think he do it, if I don't remember correctly, he just do it for the how to estimate the location of comets. But anyway, this is so common. You can see the IQ in the population, the weight, the height, or many things follow the bell curve, right? So you something like this. Okay, this is bell curve. Okay, and the bell curve has some very complicated. There's a function and this looks like this. Okay, and the discrete function is also like this. Okay, and these two are so complicated. There's no way to write calculating by hand. So to do the calculate area, okay, there's no formula to plug in directly to calculate the answer. We have to use what we call the numerical integration. Okay. So basically, it's just like there's no close. So to find, that means to find, say, this area, there's no particular function you can plug in to do the math, right? So that's why what actually do in the computer is you just find very small rectangle to approximate the area, okay? So that's why we rely on computer, okay? Nowadays, computer is so convenient, right? So we will tell you how to do it in using the Excel spreadsheet approach, okay? Instead of asking you to check the Z table in the textbook in old days. So we'll rely on the computer to do it, okay? So the main thing to remember is you do notice that we have two parameter here, right? That will determine how the bell looks like, right? The first parameter is called mu, which affect the location of the bell, right? It's left shift and right shift. And the second one is the sigma, okay? Is affecting how tall is the bell or how flat is the bell, okay? What's location, okay? Actually, turn out this is the mean, okay? And this is a spread or how high, okay? And you can see this related to the sigma, okay? And if you remember what we learned the first week, right? We learned for data, we have mean, with the variance, we have two more things about the shape, right? We have two things. One thing is called skewness, okay? And the other is called kurtosis, okay? And skewness as we have this bell shape, is perfectly symmetric. Okay. So this means skewness is 0. Okay. And remember we said about kurtosis, right? This kurtosis has always 3. Okay. Regardless of mu and sigma. Okay. Regardless, no matter you put all the sigma or all the mu, we always 3. Okay. So that's why when you do kurtosis, it's always, we do excess kurtosis, always -3. It's whether it's bigger than higher than normal or smaller than normal. Okay. And this, remember kurtosis is a tail. Okay. If fatter than normal, then it's bigger than 3. It's thinner than normal for the tail, there will be less than 3. Okay. So just to remind you that. Any question? If no, then we continue, because it's just we continue reviewing. Okay. And just to recall, this is green one, mean 0, and variance 1, and the blue one is the mean -4, variance also 1. So it's a shifting the location of the bell. If you make the green to red, it just push it down the bell, it just like increase the variance. Okay. Now, here is the main thing we want to discuss is what we call transformation. Okay. Or in this particular case, we have what we call the normalization. Sorry, is this, sorry, what we call the standardization. There are many transformation, but particular we call this standardization. Okay. What standardize? Standardize means that you minus the mean and over is standard deviation. Okay. So why this something we care a lot of time? This is what it means is everything will be converted to a normalized to 0 scale or standardized to 0 scale, right? Because minus the mean, right? So it's basically positive means above the mean, negative means below the mean, and you over the standard deviation. What means usually the z, right? Can be any value, but usually c will be between +4 and -4. Okay. But usually it's positive, -3, -3 most of time. Okay. The reason why it is always between this number, which is not explained, that is some related to some inequality, what we call the Chebyshev inequality. But it means that when you do this thing, okay, we ourselves, our mind can be focused on much smaller set of numbers. Okay. And the additional benefit of doing so will be, it's easier to compare how well you're doing, right? Right. And a normal way to compare how you perform in different classes, right, is the following, right? And I think in the primary school, right, and if you score less than 90 points, right, then usually you don't consider yourself very good, right? Because say in the math class, right, in the primary school, you should able to make yourself have more than 90, 85, right? At least 85, right? And if below 85 or 90, then probably you have a problem, right? And the teacher will probably make an appointment with your parents, right? But when you go to this secondary school and to the college or university, right? Usually actually getting 90 is almost impossible most of the time, right? So it's like 70 or 80 will be a more or less the norm, right? So even 80 maybe even is very good. Sometimes it's not even possible to get more than 80, right? And that means you, when you compare how well you're doing in your primary school or relative to your classmate, right? You have to minus the mean, right? And also it's how well you're doing about the mean, okay? And you divide by standard deviation, right? Is the way that to see to reflect the variability, right? If the variance or standard deviation is very small, right? If you're above the mean a lot, that means you're very good, right? Just look at the bell curve, right? Compare this case and compare to this case, right? If you're here, right, then it means you're top of the cream, right? But you're just here, you still have a lot of people above you, right? So that's why when we compare two numbers from two different populations, okay, and we don't look at how well it is standing, right? So you can look at this number, right, called standardization, okay? Of course, we know we can do it actually much easier, right? Because we can do the, we can see the percentile, okay? Or I can see the, you can see whether it's above his median, above his Q1, above his Q3, so on and so forth, right? But this is more straightforward to do the calculation. So this is what we call the minus mean over the standard deviation. Is called the standard, sometimes called standard score. Okay. But anyway, the focus is not telling you the application of this, but rather it's an interesting case is if X follow a normal distribution, okay, this is normal distribution. Okay, with certain mean, certain sigma square, okay, and that means this standardized normal, what we call standardized score, will follow the normal distribution with mean 0 and 1, okay? So that means that if we want to create a table to do the calculation for the normal, we don't need to create every combination of the mean and variance, but instead we just need to have 0 and 1, okay? The reason why, because we can, if we want to make some property statement on X, we can make the same statement on Z, okay? And if we just figure out how the CO1 would work, this is called standardized normal, okay? And if we know how to evaluate standardized normal, we're done, okay? And the C table, okay? Later we'll consider this, we call the, in the word, my Excel, we call normal distribution standardized. I think that is the case, but I think DST, I think, sorry, I think this would be, DIST standardized. I think this one. But anyway, we will talk about that very soon. And this will give you this, probably Z, okay? I think Excel give you any number, even Z less than 0, okay? But this one is this F of C, right? And this is something we will need for our calculation, okay? And as we said, this is symmetric, okay? So that's why in the table, usually you find in the book or internet, they will focus on bigger than 0, right? So that's why less than 0 is symmetric, okay? So that's why they focus on positive, right? Because this is 0, right? Suppose this is 0, this is positive number, okay? Because symmetry. So this area, this area, okay? The complement with the blue area, okay? And the blue area, you flip it, will become the red area. Just to repeat, right? If you look at this table, they just give you the green area, okay? And the complement of the green area is the blue area, okay? And then this is the green, okay? And one minus the green with blue, and the blue will be same as the red. Is that okay for this one? Anyway, may I have your confirmation that you are okay with that? Okay, so usually in the textbook, they only give you the positive number for this probability distribution function. Is that okay? Hold in? Yes. But the thing is, how do you calculate when it's negative? Like this is negative, right? That's that this area is negative, right? I want to calculate this negative area. Say negative less than say -2, right? Then calculate this area. How can you do it? Using the flip side, the red is same as the blue one. Is that okay, Ho in? Because symmetric about 0. And but the thing that the C table usually give you the green area, right? But they are complement. So this one subtract from the green will give the blue. Is that okay? Is that okay? But for our purpose, you don't need to worry this too much because Excel will give you all the calculation you need. Okay. So, but just in case you check the book, you don't have the Excel at your hand, then you need to 1 minus green is blue, but blue same as red. Okay. Anyway, so let me clear. So for this question, we can use C table, but I will just talk about Excel. Let's turn on Excel. But let me show you the calculation first. So the Z follows standard normal. Okay, so normal is normal CO1. And using the C table, we want to find these 3. So this can directly look at a table. Okay, and this one, if you look at a table, you just use the 1 minus. Okay, technically I have to use a net equal to, but doesn't really matter anyway because they're the same. So it's 1 minus this guy, okay, and 0.0548. And this is a negative 1.6, Z 1.4, okay. And you have to divide the 2 parts, okay. One is C less than 1.4, one is C less than negative 1.46. The reason is like this, okay. Here you have a Z 0, 1.4, negative 1.6, okay. So what you're going to do is, say suppose this is the green one, okay. The green one is you can see from the Z table, okay. This is fine. And then you can subtract from the blue one, okay, which is this guy, okay. And this guy you cannot done directly, right, because the table, okay, in the textbook, usually they give you only 1.6, okay. And the positive 1.6 can be found by the yellow one, okay. Okay. And this is yellow one you can find from the book, right? Sorry. This is you can find less than from the book. Then 1 minus yellow one will be the thing you need, right? Which is both the purple one the same. Okay, so that's the idea. Hold in, I hope that you would get the idea. But let us go to the Excel spreadsheet. Open Excel, then we just tell you how to do the calculation. But remember, don't worry about that too much because we now have all the, I think Excel have all the calculation ready. So let's open Excel. Let me share the screen to you. I hope you can see the see my spreadsheet. Can you see my spreadsheet? Is that okay? Can you see my spreadsheet? Yes. So I think the first question is less than 1.4, less than 1.4. The other question is there's 3 question here, less than negative 1.6, and that is, I think that is what we want to find. Okay, and this is negative 1.6, z and 1.4. Okay, so that complaint name I'm. Okay, so that's the fee thing. Maybe I just make it bigger. Okay, I hope you can see it. So how to find the first object, right? Of course, you can do the C table, but now we are using computer, that will be faster. So we equal to, maybe I need to make the font size big enough. Okay, so we equal to normal normal standardized distribution, and it's 1.4 cumulative, yes. Okay, it's true. Okay, so this is the normal. This is a normal distribution, standardized distribution, 1.4 true. Okay, so that would be your input. This should be the same as what we write in the oh, maybe this is font is a little bit too big. Is that okay? Okay, so for the rest, for this one will be just norm standardize this. Okay, I think you can download from the CHK website, that you can have the Google spreadsheet. But let me check if the Google should have it. But let me check now. What's the different true and false? It's always true for we calculation. The false actually calculate the density function. Okay, so let me go back to the slide. Someone asked me why the true and what difference between true and false. Let me find my slide. Where's my slide? Oh. If they true, it gives you this value. Okay, this is true. False is this guy. Is that okay for true and false? So let me see if, okay. For those of you, you can try to calculate this one. In the meantime, sorry, go back to this Excel. So you try the B3. In the meantime, I check whether the Google have the answer. So give you 1 minute, you try to give me the B3 answer. Okay, so this is your task. In the meantime, I'm trying to see the Google spreadsheet can have the ability to calculate. I think the answer is yes, but let me confirm that. The answer is yes. For the someone will ask me the Google, the answer is yes. Let me show you. Let me show you my Excel. Let me check how. Okay, so let me erase this column. I think I need to show you bigger one. So this is the Excel spreadsheet. Okay, so this is the. Can you see my screen? Oh, someone don't understand the true and false. Okay, so for the let me talk about this one first. This is only in Excel. So if you have the Google, we don't have this problem. So Google will, if you do the Google, let me change the font size because it's slightly too small. So this one you can also check by calling normal, as it's the same function, normal standard. There's no doc here, just normal. I think they have doc version 2. So they have same thing, normal doc as doc dist, and you put 1.4, will give you the same answer. Okay, so I think the formula, do they have formula? Yeah, good, the same thing. So in this one, they don't have the true and false because they always give you the thing cumulative one. Okay, so is that okay, Jung Sub? As the standardized is normal 0, 1, mean 0, and standard deviation 1. So let me go back to the several question has been asked. First, the question was what is true and false here with the Excel spreadsheet. When you say true, it's always, it will give you this one. And false give you this one. And someone asked, well, what is this S means? S is called standardized. Okay, standardized or standard normal, which means mu is equal to 0, sigma equal to 1. That's the only thing. Hello, is it clear? Because no matter which normal, you can always go to the standard normal. I mean, you will be more clear when you go to the next example, but that is what it means. Standardized means mean is 0, the variance is 1. Is that okay? So let's go back to the, if no further question, let's go to the Excel again. I think the Google is the same, but just to make let you know how to operate Excel. So that would be very standard way to calculate. It's just normal standard distribution, and then 1.4, which is true, minus normal standard distribution, negative 1.6, and then also true. Okay. So this would be same as the difference between the cell B1 and B2. Okay. For your purpose is always true for your purpose, because you are calculating probability, right? For a range, there's always true. So that's why in the Google spreadsheet, they don't even have option for false. It's always true. What makes it false? You want to calculate the height of the probability density function. It's not very useful unless you really want to calculate that thing. It's not very useful for your purpose. It will be useful when you talk about the discrete distribution, right? If you're Poisson and binomial, you will care about that. For normal, we don't really care. So basically, it's always for our class. I can safely say for our class, it's always true. I think that would be more comforting to tell you. But that actually, the integration in calculate the true one, the false will be calculate this one. But you will never need a false for our class. I can't think of scenario you need a false, but that would be, but it's good to know why you have true and false thing. Trial, is it okay? But I hope you understand the difference between the true and false. That is the main thing. But now let's just continue if you don't have any further questions. Okay. So now we are going to look at this. Okay. So here I have a x normal distribution. Okay, with mean 20 and sigma square 16. Okay. So as we said, the probability statement about x can be converted to z. So that's the idea. Okay. Just show the calculation. Okay. But of course, Excel, we can show the calculation Excel, you can directly input all this and then you're done. Okay. We'll do it in Excel in a minute after we go over all this. Then we'll break. Okay. So if x is bigger than 24, okay, so you can subtract both sides from 20, okay, and divide both sides by 4, okay, and this gives you 1, okay, and to calculate this, right, you use 1 minus, right, and give you this answer, okay, and here to here, right, okay, actually you can directly from here to here, right, later you will see from the Excel, you will call the normal this, okay, here to here is called norm standard this, okay, so that's the difference between the two, okay. Immediately we go to the spreadsheet, okay. Same for this, x is between these two numbers, okay, and you can minus the mean and divide it by the standard deviation, right? Square root of 4 is coming from 16 square root, okay. 20 come from the mean, okay, just to make sure that what is 20 and is 4, okay. This is the mu, this is the sigma, okay. We're using this all the time, okay, so don't worry if you feel weird, you'll become more familiar to you, okay. Here is x, z is become -1 and 1, okay, so this gives you the answer, okay. Let me clear this and go to the Excel and show you the calculation, and then we have a break. Okay, so here is x is less than I think I forgot. Less than more than 24. Okay, so we have the mean mu is equal to 20. Okay, and the sigma is equal to 4 because sigma square is 16. Okay, I hope that's clear. Okay, I want to calculate probability is bigger than 24, but this is can be said as z is greater than 1. Okay, we have shown you why, because 24 minus 20 is 4 over 4 is 1. Okay, so this one we can easily calculate is 1 minus the probability is 1, or you can immediately do the directly the norm standard this 1 but it's the 1 minus because 1 minus 1 and true. Okay. Is that okay for this one? Is that okay? Can you see the spreadsheet? Or because it's bigger than, the cumulative is always less than, so it's 1 minus. It's a complement. Okay. And you can, this is much bigger than 1, but you can do the normal this. Okay. But then you can see the free argument here. You have to put the x, standard deviation, and cumulative 1. Okay. So you can put 24. Okay. Mean is 20. Standard deviation is 4. And it's true. Okay. Again, you will take 1 minus because you are calculating more than. So you can see this as the same. Okay. So, but of course, in the background, they do these changes, right? So basically, the software calculate minus 20 divided by 4. Okay, so that is what is inside the software. Is that okay for this one? So I will leave you in the break if you want. You can do between 16 and 24. Oh, what to use? Doesn't really matter, right? If for convenience, you can just do it this one, right? You can do the norm this, right? Because you can input the mean and its standard deviation directly. If you standardize, then you can just do the standardized one. But if you don't standardize, this is the software calculate minus 20 and divided by 4 directly. That's this software automate that process. Is that clear? Doesn't really matter which one you use. You can standardize yourself or use the software standardize. Of course, now it becomes so easy. You can just do the simple one. Okay. So I think we will have a break until 3:35. But in the meantime, I think we, yeah. Let's have a break until 9:35. In the meantime, I would answer any question that you might have. Oh, because it's less than, right? So that's why you want to calculate more than, okay? But the function or the table give you less than, so that's why it's 1 minus.
Professor Cole，
Yes.
早晨，我想問咧，
早晨。
即係你意思話你想計 greater than 係咪真係因為係嗰個題目講話 probability that x is greater than 24，所以我要計大過？
係啦，冇錯，題目話 less than，嗰度咪 less than 咯。
OK， 好，唔該晒。
OK，唔該。 So I guess we have to resume. But before we resume, so let's see this. Any further feeling for the first question? Okay.
Hello, Professor。
Yes, please.
講中文啦，好嘛？
哦，好嘅，可以講隨
其
便。
實有個問題，因為咧我咧啲數理嘅 concept 就好差嘅，咁我就嘗試最大努力去明白啦，有啲嘢。
OK，
咁我想問，如果我温書或者理解呢課嘅方式，以背誦嘅形式，O 唔 OK 嘅咧？
其實就我建議，如果你有時間就係直接做題最簡單咯。
直接做題。
係啊。
咁如果即係你平時
你做到就會明，做到
上堂會講到啲 proof 啊，點解
我哋考試係或者做嘢都係 open book 噶嘛，咁所以你自己做題就得啦。最簡單，如果你有時間直接去做嗰一題，咁你做過幾次就明白噶啦，咁就記得噶啦。
OK，
即係好似你嗰啲quiz 啊，或者你我啲題目都好正常，求其喺網上揾啲題目都得噶，唔使話特別去咩揾嘅都好，即係基本上呢度最基本嚟噶嘛，所以邊度揾到啊？呢啲題目係係如果你有書嘅，就攞本書都可以做。
OK，thank you，唔該晒。
咁咧會有 homework 嘅，咁你 homework 咁樣做就 OK 嘅。其實你 homework 咁做，你做到你明白咁大概你就可以 OK 嘅。
OK，唔該晒。
OK，thank
you。
Oh, thank you. Let's see. Anyone who want to fill in any further? If no, I ask the second question because there's 2 questions in the pool that I was told to give you. Any further fill in? If no, then let's do the second question. I think we're a second. Other question. Sorry, let's fill in the last question because this is asked by the faculty. So can you fill in if that is okay? Just this is request by me. I guess it's also appear in other classes too. So it's not something that I particularly ask for my class. It's just the faculty asks. You just fill in. I mean, I just report back to the faculty without this tool, so I can't see the name. So basically just fill in. If in any case you just wait 1 minute and then we will resume our class.
我想問咧，喺 business school 咧啲 professor 個 general opinion 係佢哋中意 online class 多啲啊，定係 face to face
咧？其他老師我就唔係好清楚，不過我哋就我諗大部分人都唔係太中意撈埋啦，一係就 face to face，係就 online 啦。如果兩樣夾埋一齊就比較煩。
係。
咁你如果問係咯，
咁你本人咧？你本人？
我個人就 face to face 好啲，大家見到大家可以知道大家明唔明啊嘛。唔係如果就每次都問大家明唔明，就唔係好知道大家明唔明。咁但係online 嘅好處就係教 Excel 啊、教 R 啊、教 software 又簡單啲咯。
OK。
咁但係我其實都冇乜所謂，因為都係照教嘅啫，對我嚟講。但係問題就係如果見到人就會即係統計都係個危險㗎係嘛，都係有個而家個肺炎嘅比較嚴重啲，所以都係驚有啲驚啊係嘛。大家都坐得好開，其實都睇唔到身體動作嘅，其實都係大家都坐得好開嘅，就100幾人嘅 lecture theatre 坐7人啊嘛，所以就大概咁嘅情況。
呢堂我哋呢堂係完全冇 face to face 㗎係咪而家？即係全部 online 咗。
如果係大家會係覺得疫情冇問題，可能會11月會恢復翻 face to face 咯。但係 face to face 係話可以 face to face 你都係 online 嘅，即係就算係恢復翻 face to face 嘅話咧，都係會有 online version。
哦，即係可以有個 option 翻去。
係啦。
OK，唔該晒。
OK。So just fill in, and I guess I should end this one because I mean we cannot infinitely wait for everyone. So I guess we should get started. But before we get started, let me know if you have any question or comment before we continue. Okay. So let's get started. Let's get continue. So what's left is trying to give you some idea of the other distribution weighted to normal. We'll be very brief on them because you will be seeing them later soon. Okay. So we just try to provide you with some background, but you will see it very, very soon. Okay. So here is to explain why can you see the screen? Can you see the slides? Just make sure I'm not talking without showing the, okay, good. So basically here is, yeah, that's good. So here is what we have is trying to show you why the why standardized normal still normal. Okay. And the thing is why if this is true and this is true. Okay. So this proof is very fast, very quick. So that's why I want to give you some idea. So probably z is less than z. Then you can rewrite because z, x minus mu over sigma is z. So you can write x is equal to z times sigma plus mu. Okay. And that's how you write this one. And you can, because this is a number, right? You write what is the density function, cumulative distribution function. That's what you have here. Okay. And here's one trick here. We just write z is equal to x minus mu over sigma. We use the method of substitution in the integration. Okay. For those who learn integration, this is very direct. For those who didn't learn, doesn't really matter. I just show you how you arrive at this formula. And this formula is exactly same as when you substitute mu equal to 0, sigma equal to 1. Okay, so that's why this is standardized normal. Okay, you subtract its mean and over this sigma. But anyway, just for your information, you don't really need to worry about the math here because it's for technical purpose. And here is try to show you why the standardized mean is 0, and this involves just standard substitution method. Okay, and the limit of the infinity and minus infinity give you this is 2 pi. But anyway, just forget about that. And because this means 0, then because x is equal to mu plus sigma z, so using the linear property, that's mu equal to sigma expanded z, which is 0. So this is mu. Okay, so just trying to prove this is x is mu and this is 0. Okay, and this is just basically using a substitution method again. Okay, but as I said, if you haven't learned calculus, you don't need to worry about it because I just show you how this is being done in principle. Okay, and we are not the math class, so you don't need to worry about the math here. Okay. Just the next slide. This again the second moment. I just want to highlight this part. To here, we use by part, integration by part. Okay, and that is only trick used here. Other than that, it's the same. And here we use the idea this is the mean. Okay, sorry, not the mean, but you integrate all the probability. That give you the 1. Okay, the same as you sum up all the p of x equal to 1. Okay, so that is the only trick is being used here. As I said, I'm not going to detail of that because of the nature and also with the time constraint we have. We just save our time for more important thing. And variance of z will be this is what we found is 1. This is 0, so this is 1. Okay, so the variance z is 1. And variance of x, how you arrive at x is mu plus sigma z, and you add a constant, the constant is gone. You have sigma out, sigma square, and this is 1, right? So that's why sigma square, 1 is from here, okay? But here I just give you the idea behind why they're true. And as we said, we are not concerned ourselves with the math detail here. So just I will briefly go over that. For those who are still interested in math, you can continue, but otherwise you don't need to worry too much about that. Okay. So here next of the thing that I think it will be a little bit more important than the proof. Okay. So this is something that we probably use it without notice. Okay. Something like the following. If x is normal, y is normal, okay, and they're independent, then the interesting part is sum, okay, will just do normal, okay, and add up their own mean and add up their variance, okay. The reason why I can do it because they're independent, okay. If not independent, you don't have this, okay. But this will be frequently used later, as you will see, okay. We'll use it in the next set of slides very soon, okay. And same for the difference, okay. The only difference is this is subtraction, okay. The variance to add together, okay. There's nothing to understand or not because we're just saying this property. This is true and this is the fact, so you don't need to worry whether you understand or not. You just know it and we'll be using it, and that's the only thing. Okay, so there's nothing to understand. It's just something we say it without proof. Is that okay? Can I? Yeah, it's just nothing to remember, just nothing to understand. It just give you, this is the fact, we will be using this. Actually, we're using this in the our next class, or maybe if you have time with this class, but just give some idea. Okay. So the rest of the slides will be just not particularly important, but just give you some idea of what we'll be using for the rest of the course. There will be some other distribution that we'll be using a class. So the first one is called the chi-square. Chi is written as this. So it's very similar to x, but just I think it's Greek letter. I think it's Greek letter. So chi-square actually just, the origin of this is just people want to have x square, standard normal square, okay? And then turn out to be someone who do the printing machine have picked the wrong thing. They think x and chi are the same. So that's how turned out to be the error of the history, okay? So what we have is squared standardized normal. It's a chi-square 1, okay? So this is something like degree 1, so something new to you, okay? So what it is if z is the standard normal, its square will become the chi-square 1. So what it means is if a bell curve, okay, you pick up some number here, it is standard normal, right, with mean 0, okay, sigma 1, and you take it square, okay. The one you have is called chi-square degree of freedom 1, okay. Again, there's nothing to understand. It's whether you know it or not, okay. Is it clear? So there's nothing to understand, but just to remember And later you will see why we need them, but and turn out to be if there's n independent standard normal, okay, and C1 square, right, is chi-square 1, okay, and this is everyone is chi-square 1. If you have n chi-square 1 add together, then it will be chi-square n, okay. So that is the idea. And once chi-square n, there's a function for that, but we're not going into detail to give you the expression, okay. Later when we learn ANOVA, the second last topic, and the regression, okay, this we will talk about chi-square. But for the moment, this is what chi-square is. Just you can imagine this is basically x squared, just standard normal square, and that's it. Yes, it's not symmetric because square, right? It's always the minimum you can get is 0. Yes, it's not symmetric. So that's why you see a very good question. So that's why when you see the graph, it's not symmetric. Look like this kind of shape. Of course, very good question is if you have a lot of chi-square infinity, a lot, you have many together, that will approach normal. Okay, there will be something like this too. So if you have many, there will be something like the normal distribution. But anyway, it's not a concern for us today. But that would be, it will be more, okay, put it this way, to be easier to think is like if you add more and more, it will be more symmetric. But otherwise, it will be less so. I hope that's okay. But it's no longer symmetric. But it's not important for our purpose. But it's good to know. But just know chi-square is just a standard normal square. Okay. And T, okay. This is called student T. Okay. Sometimes you see textbook. Because it's not invented by a student, but it's just someone who write a pen name called student. Okay. Oh, it's pen name. Sorry, it's pen name. But anyway, I think this is invented in 1930 something. Okay, anyway, it doesn't really matter. What it means is if x is standard normal and y is chi-square with degree of freedom m, okay, and this particular object, very funny object, x over square root of y over m, okay, you may wonder what it is, okay. Later you will see this is so commonly used, will be equal to TD with M. Okay, we'll do it in the next set of slide. But this is so important. Okay, this will be, I would say, this is almost the single most important thing in the class, next to normal. Okay. Okay, and you will see normal and standard T division is so close together. Okay, and this will be the T will be the almost the most important thing. Okay, for our purpose. And one important fact, one thing you know, actually you see in the next slide, when M get bigger and bigger, you will be very close to normal CO1. Okay. But anyway, there's nothing to understand right now because it's just some introduction of certain type of graph. So just give you some idea. You can see T equal 1 will be just this guy, and 5 you go up, okay, and up and up and up, okay. So it become fat tail to the to normal, okay, fat tail to normal distribution. When you go to infinity, it will be normal distribution. And later you will see why we talk about all this. But at the moment, you just have some idea what we're going to talk about, okay. So just some concept later you will see. It's T, And the last one, okay, this is also very important beside T, is called the F distribution. And what it is, if the two chi-square and the independent and the ratio, okay, x over m, x remember is m, and y is n divided by degree of freedom, okay, we will call F distribution with degree of m and n, okay. And degree of freedom, just go back to the chi-square. Degree of freedom is just 1z square, okay. Chi-square degree of freedom 2 will be 2z distribution add together. If that means the degree of freedom, degree, okay. And so you can imagine that's m standard normal square add together, n standard normal together. The ratio of them will be m and n, okay. Just a parameter. You can imagine this. F has two parameters, m and n, and tell to be later we call degree of freedom. And what's degree of freedom? Later we'll see in the application. It will be something that is you can imagine M degree of freedom is like the how much thing you can change. Okay, it's not easy to explain at the moment. It's something that you can think is if m and n as the input. Okay, degree of freedom will be somewhat very the term is with two input. You can say. I agree that I'm not answering satisfactorily because to fully appreciate the term, we need to understand the math behind, and then we cannot touch it. And when I was a student, I also have this question what it is. And you can't fully appreciate until at the end of the day. And actually this is related to somewhat idea we learn about, remember when we learned the variance, right? We divided by n, right? But I mean, it's just summation x minus x bar, right? But s square, we divide by n minus 1, okay? And actually, this one is somewhat like degree of freedom, okay? It's somewhat something that we can't explain where we have some explanation, but later you will see it's just some input, you would say, okay? I don't think I answer you very well because it's very hard to answer very well without knowing the math, but just some input. And later you will see how to use those input. I'm sorry for that. I mean, I also have the same question all the time when I was in the university for the 3 years. Until I study my PhD, I would able to get somewhat. But I cannot safely say I fully understand the concept. But when I do the math, that will be very clear that this is what degree of freedom. But it's not easy to understand at the stage for you. You can just consider there's two input there. That is the easiest. Until you get to the math side, otherwise you just say there's two input. I know I didn't answer you perfectly, but I think the best is to sometimes to study math in B school or statistics. Sometimes you have to leave the problem with you. Okay, learn to leave the problem. That's something you cannot fully understand everything, because to understand everything is too complicated. So you have to unlike the primary school and secondary school, you have to bear with it. You have to learn how to have something that you are not able to explain all the time. Okay, I'm sorry for that, but that's life, right? There's something not everything you can explain, right? So I'm sorry for that. But I guess that is pretty much for this set of slide. Any question? This F looks like this. Usually depend on the input A and B is look like either is downward sloping or they are looks like more chi-square. And they are very useful. Later you will see, but so don't worry about the input, the M and N. when you use it, you know what to put in there. Okay. But you'll be very clear. So the use of them are very easy, but looks like very intimidating, I would say. Okay. Any questions so far? I will not talk. So you can consider the class end as slide 47. Okay. The 45 onward will be, you can say we just preview what will happen. So for the next class, we will do the quiz. Oh yeah, sorry. Because they are just some facts, so I cannot, not even to explain. So later you will see. But I think for the slide 75 onward, you can just treat it as fun. Okay, you use it later. Okay, for the purpose of quiz, you can forget about the chi-square onward. Okay, but you will see it very soon. Okay, so the quiz will be basically next class will be asking you the just asking the uniform, exponential, normal. Okay, chi-square, student T and F will be something. For the moment, you can forget about it. Okay. Okay, because there's nothing to ask at the moment because I didn't take any content. Hanno, okay. What is Hanno? Sorry, oh, okay. Okay, so if any question, then we just go to, oh, you can use it. Of course, you need to use it because I asked normal. You need to use it. Of course, you can use the book, but yeah, feel free to use your Excel to do calculation. Yes. Okay. So if no further question, then it's for someone just to ask me whether the quiz for grade, no, quiz is for attendance. Just the quiz will be just uniform, exponential, and normal. But you should revise for the quiz, right? Because that is the purpose of the quiz. You just take some revision and you know more, and you know where you know what to. With exercise, yes. I will upload the exercise. Actually, I want to do it on Thursday, but since people ask me the exercise, I will be uploading the exercise assignment 2 that will be talking about chapter 3, 4, and 5 that you can do more. Is that okay, Ho-In? I mean, you can do assignment. You do assignment for you. It'll be 2 weeks. Give you 2 weeks to do it. Of course, I supposed to give the homework after the homework 1 is done, but since you guys are very enthusiastic, I just put it earlier than I supposed to do it. But anyway, any further question? Otherwise, we will just only one is 16 years. But I just put it on because many of you seems to be very eager to do exercise. So I just put it there in case you want to work on those questions. But otherwise, you will not be formally available only after you're dead of the first assignment. But just put it there in case you would be interested in doing the questions. But I mean, you look at the next quiz is just continuous distribution, uniform, exponential, and normal. Just from slide 49 to slide 47. Is that okay? Whole law? Yeah. More time, I guess the 1-page summary should not be taking more time, right? I think Vicky. Is it a lot? I mean, 1-page slide and 1-page. Oh, assignment 2 have not been released yet. It's not been released yet. Just people want to do it. We will be more time. I think I'll give you 2 weeks for doing. I think the end of the October. But let's see what we can do. I'll ask the other class if need to give you 1 more week, but otherwise we can try to see if we give you 1 more week for that. But other than, but you will see the assignment is not very complicated. Yeah, any type of analysis, you just want you to apply the concept directly. Okay. Any further question? If no, then we just very briefly to go over the sampling. It's just very brief, so don't worry about that. But any more question? So assignment 2 is not released yet. I just put it there because, okay, I just put it there because someone want to revise. But I don't put the due date yet. Probably we'll talk about that after the quiz. The quiz is next class. Just constitution. Just to repeat, the quiz is just a few pages. Just from 49 up to 47. That's it. But don't overlook this chapter. The constitution is so important. We're using it all the time. Okay, so it's good to have a short quiz on that because this is so short, so the quiz will short. So don't worry, it will not take too much time. As we said, it's just attendance based. So just do your revision and then you will learn a little bit more. Any further question? If no, we just although we have a few minutes left, but I want to give you some idea because that would be speed up our class. It's a little bit slower. I think we're 1 week behind, but I think should be fine. Any further question? I mean, feel free to ask. If no, then we will. Any further question? No? Okay. If that's okay, then I just give you a very brief view of this. Then next class we will continue for this one. So the sampling distribution, okay. And the main idea of sampling distribution is we do sampling, okay. And the reason we want to do sampling is because the real world we have some data, right? Okay, we collect the data, okay, should be the world, right? Okay, we collect some data, and how to collect some data, right? Unless we are able to collect every single object we want to study, the world. Sometimes we refer to what we call population. Okay. Okay. We're not going to get everything from there. That's why we call sample. Okay. And we have the data there. And what we learn is from the data, we try to infer back. Okay. Infer. Okay. Or what we call the educated guess. If you want a next technical term, educated guess. Okay. The educated guess what happened in the world. Okay. For example, we want to see, we just did it, right? How many people would like to have class online or face-to-face, right? That is also, we're not going to get everyone. Actually, not everyone do it, even though everyone is here, right? So only 20-something of you are listening. No, probably, maybe just feeling. In that case, that would be, we try to guess what happened, right? Or we try to see, right, the US election, right? We always try to see how many people support Trump, how many people support the Biden, right? And in that case, we cannot ask everyone. Asking everyone only happened in the election day. Before that, if we want to know how the support level changes, right? Just we need to be collecting data, okay? And the way you collect data is something is very complicated, okay? is not in our class, but how to collect the data is a very complicated item, complicated issue, right? Every day you see data called, say, CPI, right? Consumer Price Index, right? Consumer Price Index, right? This used to calculate inflation, right? This is something I hope for business school student, I hope that's something you know very well, right? And is how do you calculate this, right? Is to asking how the average consumption basket, right? Is asking how much you spend on food, you spend on housing, spend on transport each month, right? And then you are looking at consumption of average consumer, right? How do you calculate the average consumer, right? Is trying to pick up, say, 1,000 people, right? And then ask them the spending pattern, and you get from those. And you will clearly notice that these the job of picking who will be in the study will be very crucial, right? If you pick the wrong one, then you always have the wrong answer, right? Just like in the US election, if you go to a blue state, likely you get the people who support Biden. You go to the red state, likely the people who support Trump. Okay, so the same idea here, right? And even in Hong Kong, if you ask one question to one group of people, we'll give you very different answer if you ask another group of people, right? So you have to be make sure that if you want to be fair or get an accurate answer, the simplest thing is what we call simple random sample, is to make sure that every single element has equal probability being selected and each selected independently. And that is very difficult, right? Because say sometimes you have the phone, right? You pick up the phone, someone call you, and you notice that it's not random because some people would put down the phone, or some people don't even pick up the phone, right? Most of the time I don't pick up the phone, so there's no point of calling me. But email I always answer, but usually I don't reply to phone. But that means that if you do a survey, then you always miss me, right? Because I never usually don't answer to the phone, right? Because most of the phone a lot of the phone are just annoying advertising, right? So if the the survey is going to ask, right, then you miss me and miss a lot of people who don't like the phone, or some people who don't have the phone at all, right? So select independently and equal probability is very difficult indeed, okay? And sometimes the geographical constraint, right? Say, look at the US election, right? The blue state and the red state, right? Say California is very big, have a lot of people, right? And say compared to, say, maybe Wyoming, right? And then there's two different states and the two different population, and there's likely to different political affiliation, right? And in those cases, these two are very difficult, okay? But anyway, step aside, when we mean the random sample, here, this is the definition, okay? So, but just to, this is conceptually what we mean by simple random sample. And what we call the random variable, okay? X1 to xn, okay? And are called n observations from and sigma square. What does that mean? So what does that mean? Okay, a simple random sample means that each xi, okay, each xi, okay, will have the same mean, okay, and the variance xi with sigma square, okay. This called simple random sample because they select independently, okay. Just an additional fact, probably should know, any covariance will be 0, okay? I not equal to j, okay? x1, x2, the covariance will be 0, okay? Because they're independent. Is that okay for the definition of sampling? So I hope you understand why we need sampling. So I want to end, so sorry to overrun a little bit. I want to give you the first result, otherwise it would be too abstract, okay? So let me, very briefly go over the result and then we talk about the proof, okay? Next class. So sample mean is the mean of a sample, okay? So it's very interesting, but what it means is x1 up to xn, right? So this is the sample number. You add them up, divided by n. So that's the meaning. Okay. You draw the random sample. Okay. Just like you roll a die, you get numbers, right? Your mean of them is called sample mean. Okay. That is exactly what it means. But do note that while you laugh, I understand it's a very funny name, but turn out to be this is a random variable too. Okay. Do note that. Because why is the case? Because this number depends on what we draw. Every number depends on what we draw, right? Just before you draw, you don't know the number, right? It can be any number, right? Just ask, you support Trump or not? X1, right? Xn will be different, right? So that's why at the end of the day, this sample mean will be something that you don't really know, okay? And I just give you the result. I'm not going to talk about that anymore. So just one slide. So sorry for overrun. Just bear with me. I hope that's okay. I guess there's no bus to change for today, right? I guess overrun 1 or 2 minutes, you will not mad at me. So the expectation, okay, that's very interesting point, okay? The sample mean is the mean of the sample, okay? The expectation of sample mean, okay? Or what we mean by mean of the sample mean is a population mean, okay? So what it means is, okay, it's very complicated meaning, the mean, okay, is you have many sample mean is possible, right? Depend on what the sample you draw. And on average of this sample mean, it's same as the population mean, okay? Just to repeat what we said here, okay? So the population has a lot of number, okay? And you can calculate, if you know everything there, you can know the sample mean. So you know the population mean, okay? Which is adding every number there. And what we said is, first, suppose we go into draw one sample here. We calculate the first sample mean, okay? And we draw another sample mean here, okay? And then we draw all these possible sample. So maybe other color. So another color, we draw another sample, okay? And the average of all this, right? You can calculate all possible sample mean, and or I don't know how many of them you can have, maybe m of them, divided by m, okay? Turn out to be, you get the population mean. They can overlap, they may not overlap, because independent. So all possible way. So later you will see example I will give you. Is any possible sample, can be anything, okay? Because simple random sample is each one can be equally likely to draw, okay? Just like there's a ball here, it's just sampling with replacement, okay? So you just put ball there, you draw one ball here. Oh, this is the ball. Put it back and draw again, okay? And what it means is the expectation of all this sample mean, okay, will be the population mean, okay? So that is the key thing here. It means that what we call the unbiasedness, we'll talk about that next class, is a good thing because what we want to guess, okay, on average, if you repeat many times, in principle, we get what we want, okay? So that's why when you look at the election in the US, some people would aggregate the survey result of many pool, and then they give you a very accurate estimate. Okay, you can overlap. That's no problem because they're independently drawn. Okay, so I'm not going to talk further because I think it's over time, but we'll repeat a little bit today, review next class. But of course, we have the quiz first. The quiz will be short, but hopefully we will finish it. Okay, just for review today. But anyway, I should end today. So let me know if you have any question. So stay safe is typhoon number 8, although a look at outside is nothing. But I hope you don't go out. Stay safe. Enjoy the holiday. And then I will see you next class. Remember there's a quiz. Okay. So see you. Stay around to answer the question you might have. Bye bye. If you have any question, just ask. But otherwise, so please feel free to ask question if you have any.
阿 Sir，
你講。
我想問，我想用 Excel 嚟計即係嗰啲 SD 啊咩嗰啲啦。咁但係我唔係好識點樣撳，即係例如我當有20個3咁樣，即係3，但係我唔知點樣撳喎。
其實我哋有教過 variance 個問題嘅，不過我可以再做一次俾你睇啦。又睇翻之前嗰啲 video 得嘅，但係我可以做一次俾你睇啦。譬如話呢度睇唔睇到我個 screen？ 睇到。So someone asked me how to do the variance. Okay. So you have data 3、4、5咁啦。咁 variance 咪就咁撳 variance 咯。variance P population 啊嘛 ，highlight 咗佢咪得咯。咁 variance
呢個係有得3個 data 係3、4、5咁樣啊嘛。即係如果有好多個3咁樣，咁點樣計啊？
點解好多個3？咁你咪有好多個3咪咯？
係啊，即係因為份 assignment 係要做即係整一啲即係分析嗰啲 data 啊嘛。咁佢一個 data 好多個咁樣。
哦，咁你咪乘咯。你咪要計翻嗰個，你要計翻嗰個。OK. So the question is like this, right? So suppose you have suppose you have this is data, right? And this is the frequency, right? So basically we want to change the frequency table to the variance, right? Suppose you have 10, 3, 11, 4, and 5, 12, right? This is something what you want to ask, right?
Right.
Then you start from first principle, right? First, calculate the mean. How to calculate the mean? So that's why you always need to start from beginning. So mean 就係咁樣計噶嘛。你呢個乘呢個啦，咁你加埋3嚿嘢 ，OK？ Then sum of them divided by sum of them。呢個得唔得？
哦 ，mean OK。
This is a mean, right? Is that okay? 得唔得
？OK。
咁你個 mean 之後咧，咁你咪要計個 deviation from mean 啦，係嘛？因為每一個減 mean 啊嘛。係嘛 ？deviation。咁所以你咪呢嚿嘢減呢個啦。我用 absolute address 啦，得唔得呢個？
哦 ，OK。
明唔明？咁我要 square 㗎啦 ，square deviation 快啲啦，費事咁多嘢做啦，係咁多步啦，得唔得先？呢步得唔得？
明嘅。
咁即係話咧，我哋減咗 mean 啊嘛，得唔得？
係。
呢個叫 square deviation。OK， 咁咪照乘咪做完咯。嗱，咁你呢個 每一個嘅 deviation 乘翻嗰個 frequency， 加翻佢，咁個 sum 咪就係答案咯。呢個就係 variance 咯。divided by sum of 呢個，睇下你要揀乜啦嚇。Depends on 你係計 population 定係計 sample 啦。咁咪做完咯。
OK，
咁呢個就係 variance 咯。你明唔明我做緊咩咧？
明。
就係咁咯，得唔得？
拜拜。
So this is the variance.可唔可以啊
？OK， 明白。
Good. Okay, thank you. Bye bye. So let me know if any further question. Any question I can help you. But I have to go in very soon because the next class is there. But any more question? Because if no, then I would end the section because of obvious reason I need to go. If there are no question, any more questions? No? Anyone? Rafi, Poison, Yu Zheng, and also Saransh. No? If any question, you can ask me next class, or you can email me because I soon need to go. Any further questions? If no, then I will say bye bye. Can I? Bye bye.